Welcome to part 1 of the video on iteration by parts. In this first part we're going to introduce the idea of integration by parts, and we're going to solve one example. What is the idea of integration by parts? The idea is to use the product rule from derivatives for solving integrals. And to do that we need to remember what is the product rule. The product rule says that when you have the product of two functions, u of x and v of x, and you take the derivative of this product, what you get is given by this right side of this equation. You get u prime of x times v of x plus u of x times v prime of x. This formula is called the product rule for derivatives. And what you can do to use this formula and apply it to solve integrals, what you can do is to integrate both sides of this equation. So we get that the integral of the left side equals the integral of the right side. Here on the right side we have the sum of two functions. So the integral of the sum equals the sum of the integrals. So we get the sum of integrals here on the right side. Now, what happens when you integrate the derivative? Here on the left side we have the integral of the derivative of this function. And we need to remember that by definition of indefinite integral, you get back the original function that is inside the brackets here. That's just by definition. So this left side equals the original function inside the brackets that equals u of x times v of x. So we can replace that in our formula and we get this equation here. Now we're going to subtract this term, that is this integral, to both sides, and we get this. We subtracted here on the left side this term, and on the right side we subtracted, and it cancels with this one. And we can take this right side to the left to get this formula for this integral. And this equation, this formula, is the formula of integration by parts. And when you say I'm going to use integration by parts, what you mean is that you're going to use this formula for calculating this integral on the left side. And why is this formula useful? Well, there are some times when you take an integral and you express it as an integral of this form. Instead of calculating this integral, you only need to calculate this other integral, and hopefully this other integral will be much easier than the first. And we're going to see how that works in an example. Let's consider this integral. This is the integral of the product of two functions, and this integral cannot be solved with any of our previous methods. If you use substitution, you won't be able to solve this integral. So let's try integration by parts. The formula is this one, and in this case we have a product, so it is quite easy to apply this formula, because in this case we can make u of x equals x, the first function, and v prime of x equals e to the x. And here on the right side we have u, v, and u prime. So we need to find u prime. U prime of x will be 1. And here we also have v, so we need to find v. And to find v, we know what is v prime of x. So to find v, we need to find the indefinite integral of this one. Then in this case equals e to the x also. So you only need to replace in the formula. Here x is u of x, and e to the x is v prime of x. So according to the formula, this equals x times e to the x, where x is u, e to the x is v, minus this integral, where 1 is u prime of x, and e to the x is v of x. So we have this equation here. So we need to solve this integral on the right side. And in this case, it's much easier to solve this other integral, because the integral of e to the x is e to the x. So we can factor the e to the x and we get this answer. That's the final answer. So in the following videos we're going to solve more examples using integration by parts. That's all for now. Thank you for watching and see you next time.